Hey there, algebra. Let's jump into lesson 13. It's our second part of lesson 12, which was about exponential graphing. So in lesson 13, it's reasoning about exponential graphs part 2. I should have set this up. Page width. There we go. All right, hold on a second. I need to do one more thing. All right, so today we are learning how to identify the initial and growth factor of an exponential function given a graph showing 2 points with non-consecutive input values. So input is, remember, our x-axis. So non-consecutive input values. So it's not one right after another. Okay, so identify the initial and growth factor of an exponential function given a graph showing 2 points with non-consecutive input values. Also, interpret the intersection of the graphs of two functions that represent a situation. All right, so let's start out with which one doesn't belong. Anything, right? If I look 8 times 2 to the n, cool. 2 times 8 to the n, okay. This one is not exponential. It is linear. I know that because my exponent of the variable is a 1, and it's not in an exponential spot, and there's addition in between the two numbers. So I think that one doesn't belong. Okay, the rest of them are all, this is exponential growth, this is exponential much bigger growth, and this is exponential decay. All right, value of a computer. Here is a graph. Why did this get? Here's a graph representing an exponential function, f. The function f gives the value of a computer in dollars as a function of time, x, measured in years since the time of purchase. Okay, so 400 all the way down. Based on the graph, what can you say about the following? So the purchase price of the computer at time, so this right here is our input, which is time. It is independent. It's our domain, etc. So that's years since the time of purchase. So here I have time equals 0. So at time equals 0, my purchase price was $400. Okay, that is my vertical intercept. Is 400. The value of f when x equals 1. So somewhere in between here is the value of f when x equals 1. It looks like when time equals 2, I'm down to 100. So I'm going to guess that when time equals 1, I don't know why I put a plus there, I'm cut in half. Then time equals 2, I'm in half again. And then when time equals 3, I bet I'm in half again. Hi there, Kim. And then when time equals 4, I'm in half again. So the value when x equals 1 is $200. And the meaning of f of 1 equals the value, want to make sure I use the right word, of the computer one year after purchase. Okay, that's what f of 1 means. How the value of the computer is changing each year. The value is decreasing by half. Each year, the value decreases by half the amount. And then an equation that defines f. So we have f of x, I think it's x, it should be time, so I could use anything, but it says x. F of x equals my initial value times the amount remaining raised to a certain time, x. and whether the value of f will reach 0 after 10 years. So we can calculate it. F at 10 equals 400 times 1/2 raised to the 10th power. 400 times 0.5 raised to the 10th power. That computer is worth pennies. 39 cents. So not 0. Basically 0, but not exactly 0. Make sure I'm not missing anything. Yep, a little less than 40 cents. Here are graphs of two exponential functions. For each, write an equation that defines the function and find the value of the function when x equals 5. So here I have my initial value as 5. We're going to call this, I don't know, a of x. My initial value is 5, and it looks like at input 1, I've gone to 15. I think that's a tripling. And then input 2 is 45, because 15 times 3 is 45. Yep, so I'm tripling each time period. So 5 times 3 is 15. And then times 3 is 45. Cool. We'll call this b of x. Looks like my initial value is 20. And I don't know what happened at 1, but I can figure it out. So if this went to 10 and then to 5, that means I'm going down by half. Oh, I didn't even see the 40. Good catch. So half of that is 20, half of that is 10, half of that is 5. So we definitely have a decay of 1/2. And then find the value at 5. 5 times 3 to the 5th power. $1,215. And then here we have evaluating at 5, 20 times 1/2 raised to the 5th power. Definitely smaller. Okay, that's going to be the value out here somewhere. Pretty small. And out here somewhere. Decently big. Are you ready? Okay, email me for a bonus point on your next quiz. And then moldy wall. Here are graphs representing two functions and descriptions of two functions. So function f, the area of a wall that is covered by mold A in square inches, doubling every month. Function g, the area of a wall that is covered by mold B in square inches, tripling every month. Which graph represents each function? Label the graphs according and explain your reasoning. So G is tripling each month. We'll keep that in color black pen. And function F is doubling each month. So G is growing faster. So G is this one right here because it's growing faster. And here I have F growing a bit slower. Okay, still too fast, but I'm growing a bit slower. So doubling is slower than tripling. All right? We don't have the same starting point, but that's not a big deal. It wasn't described that way in our problem. Then which graph represents, oh, did that one. When the mold was first spotted and measured, there was more of mold A. Or was there more of mold A or mold B? So when it was first discovered, that's at time equals 0. And I've got my dashed one, which is mold B. No. F is mold A. So dashed, mold A has more initial amount of mold. And then mold B, smaller. So it started out with less, but it's growing faster. What does the point PQ tell us in this situation? So in this situation, P and Q is P is the time in months when mold A and mold B have the same amount. And that amount of mold is Q, square inches of mold. And that's it. That was short. All right, again, lesson summary is fantastic. Not just saying that because I'm the teacher. All right, good job today.